All right, welcome class to lesson 10. It's hard to believe we're already to the 10th lesson in Unit 4. Time is flying. All right, so today we have a lesson around dividing by unit fractions. All right, so the first thing I want to show you is that there's a neat fractions tool here that you can use. It's linked in your Classic assignment, and you click on it and it'll look like this. And this might look like kind of a lot, so what I've done is I've included a tutorial video to show you how to use this tool. And just in case it's blocked with our school internet, I'm going to go ahead and play it now. All right, so I will play it now, so you'll have access to the video here in case it doesn't work on the devices at school. So I'm going to show this for a couple minutes, and then we'll come back and go through the questions below.
Hello, I'm going to use this tool to show how many 1/2s there are in 3. So first I need 3 if I'm going to figure out how many halves there are in it. So I can either use this slider to set that value, or I can type in this box a 3 and press enter and it will set it to 3. I want to see how many 1/2s there are in it. So I'm going to set that number down here. When I'm talking about 1/2, the denominator is 2, pressing enter, and then the numerator is 1. So there's my 1/2. And up here we can see there's a light blue rectangle that's the same size as one green. There's one light blue rectangle, but 1/2 of it is shaded in. Here's a 1/2. So if this green rectangle is a 1, this shaded blue part is 1/2. And now I'm just going to use the tool to count how many of these 1/2s there are in 3. And I can use these markers to mark them off. So there's 1, there's 2, there are 3 1/2s moving right along, 4 1/2s, 5 1/2s, and then there's the 6th 1/2 left over. So now I can see that there are 1, 2, 3, 4, 5, 6. There are 6 1/2s in 3.
All right, so I'm actually going to go ahead and delete this link here as we don't need it anymore. We have it in the video. So, all right, so getting on to our work for today. So, number 1 says to find the value of 6 divided by 1/2. Elena thought, how many 1/2s are in 6? That's what this question is asking, right? So she's just kind of restating it in a different way that might click for her a little bit better. And so she drew a tape diagram, and it shows 6 ones with each one partitioned into 2 equal pieces. Partitions means they split it up. So you can see here, this is like one whole, and then she split it into 2 pieces. So that means this piece is 1/2. Each piece is 1/2, right? And so you can go, and you can count all the pieces. How many pieces are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 pieces. Okay, so that's what it looks like on the diagram with 12 pieces. So you take 6 holes, label those, and then split those holes into halves. Okay, so let's go ahead and see if we can follow her lead here. It says for each division expression, complete the diagram using the same interpretation of division as Elena's. Then write the value of the expression. Think about how to find that value without counting the pieces in the diagram. So we'll use the diagram for a little bit here, but then I want to see if we can move away from the diagram. All right, and some of you, I'm sure, already have an idea about where we're going to go with this, but let's see it with the diagram first. 6 divided by 1/3. So you can see this is actually just the same length as the one above. That's okay. We're just going to go ahead and take 6, and we're going to divide it by 1/3. So the idea is that we're going to take the denominator here, the 3, and that is going to be the number of, or the number of pieces that there's going to be split into. Okay, so the idea is we're going to take this 3, and that means we're going to make 3 parts here. So this is a whole, but I'm going to go ahead and break this into 3 parts. So there will be 1 part, and there is another partition. And so if you look at it, this was one hole. Okay, this was one hole. I'm going to leave it. It doesn't have to be exactly perfect. But now it's 3 parts, right? You can see that. And so if we go through, so for each of these, I'm going to go ahead and do the same thing. Here's another hole. I'm going to put, you need 2 partitions because 2 partitions will make 3 pieces, right? So there's 3 pieces there, right? So same thing. So for each one, I'm going to put 2. So here's 1, and then let's go back and get another one. There we go. All right, so we want to get them as close to evenly spaced out as possible, but we're all human beings, so it's okay if it's not exact. It's just important to understand that they represent the exact same size and space. So trying to get it to be as close as we can. Okay, and then so last box here, 1, and there we go. Okay, so the idea is that for each of these boxes, it is 1/3 of a piece. So we can go ahead and we can label this in here 1/3, and I'm going to make it the smallest we can make it. Oops, I need to change the background out. We want no background. All right, so you can see here then that 1/3 is the size of each piece. So if we were to go through and count and see how many pieces are there, okay, if you count these out, let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There we have it. So the value of the expression then would have to be 18. All right, in this case, we have no idea what the units are or what it's about. It's just 18 for now. All right, and we'll make it 1 notch bigger. All right, so right now, given the fact that I've already explained this to you in previous lessons, I'm going to go ahead and give the trick away here again for you to see. So if you look at what happens with Elena when she's dividing by 1/2, okay, remember this was, we said this was going to be 12, right? We knew it's 12. Look at this. Do you see something here that she could have done to get 12? Do you see where she could have taken 6 and multiplied it by the denominator? Right? 6 times 2, that's 12. 6 times 3, that's 18. What do you think is going to happen here? It's going to be 6 times 4, and we know that is 24. Okay, so I know they wanted us to kind of go through and make all of these here, and if you can, if you'd like to, but mostly I want you guys to understand what's happening here. You can see how it looks on a diagram, so you can get that. It's the actual explanation of how it works, but once you get that explanation down, then you want to go ahead and move on to the most efficient way to solve these. All right, so if we look here, 6 divided by 1/6, right now you guess that's going to end up being 6 times 6, right? We've already done the part, you did some in 5th grade as well, where you know to multiply by the reciprocal. Okay, so this is the idea, and this is going to build into our next activity, where it's not going to be quite as easy, but it's just going to be adding on one more step. All right, so it says here, analyze the expressions in your answers, look for a pattern. How did we find how many 1/2, 1/3, 1/4, or 1/6 were in 6 without counting? Well, of course, what we did is we just ended up taking the 6 and we multiplied it times the denominator. Okay, that's all we did. That way you didn't have to count individually every time. So that's what we did. All right, so based on that, they want to give us a few more practice problems to do here. They mentioned that if you get stuck, you can draw diagrams, but they're not expecting you to draw diagrams every time. And in fact, as you get older, you probably might not draw a diagram very often at all, but it helps to understand it. So that was the point of that. So 6 divided by 1/8, you know this is going to end up being 6 times 8, and that's 48. 6 times 1/10, that's 6 times 10, that's 60. 6 divided by 1/25, that's 6 times 25. We can do that in our head because 25 is like a quarter. And we know 4 quarters are in $1. So you have $1, but then you have 2 more quarters added onto that. So you have $1.50. Now in this case here, there's no decimal point, so it's not 1.50, it's 150. All right, and then 6 divided by 1/b, that's actually a b there. Well, we don't know what b is, so we can't actually do 6 times b, so we're just going to have to write it as 6 times b. So we would just say that this is 6b. Move it up so it's right next to it. It's just 6b. Okay, all there is to it. So by now we want to get on and see if we can move a little bit faster, right? 8 divided by 1/4. Well, that's the same thing as 8 times 4. 8 times 4, that's 32. 12 divided by 1/5. That's the same thing as 12 times 5, and 12 times 5 is 60. All right, a divided by 1/2. Well, it's no big deal. We don't know what a is, but we know that it's going to be a times 2. So we can write this out as being a times 2, or we can call that 2a. And then down here, a divided by 1/b. Well, that's going to be a times b. And you can actually just write that as AB. We just put those letters together. All right, so hopefully this helps. Now you'll see when we get to the next activity that you can't always just do one step that quickly. So there's going to be another step we're going to introduce for different kinds of problems.